All right, so here we go. We are looking at the last lesson in Module 3, lesson number 7, where we are going to be creating linear and exponential functions. So starting at the beginning, it says, recall that the general formula for a linear form of a linear function is f of x equals ax plus b, where a is the slope of the line and b is the y-intercept. So again, previously, you've known this to be y equals mx plus b. When we're looking at functions, we change our y to the output, which is f of x, change our slope m to a, so we'll have ax plus b. So you can write an equation to model a linear function from a pair of input and output points in a table of values, from a graph, or from a verbal description. To write the equation for a linear function, determine the slope from any 2 points on the line, and then substitute that in for a into the general form, then identify or determine the y-intercept and substitute that for b in the general form. A lot of big words, not big words, but just the description's not great, right? What we're doing is we're just writing equations of lines like we've always done. So when we take a look here, it says Donovan earns a weekly dollar amount in addition to a commission based on the amount of sales he makes. Last week, Donovan made $3,000 in sales and earned a total of $580. This week, Donovan made $2,000 in sales and earned a total of $520. Which linear function best models this equation or this situation? So remember, we're looking for this formula here. We need to find the A and the B. So to find the A, first I'm going to take our information and kind of put it into a table here for x and f of x. Remember, f of x is our output, which is y. So if we start the first input they gave us, right, was 3,000. And if he made $3,000 in sales, he earned a total of $580. The second input they gave us is if he made $2,000 in sales, he made a total of $520. So what we first want to do is find the slope. So just like whenever we're finding the slope, we want to find the difference in y's over the difference in x. So if I'm finding the slope, I can take 580 and subtract 520. That's our difference in our y's over 3,000 minus 2,000. Now, if we just continue this out here, 580 minus 520 is 60 over 3,000 minus 2,000 is 1,000. And then if we do 60 divided by 1,000, we get, 60 divided by 3, we get that our slope is equal to 0.06. So if we're looking at these problems here, right away we know that we're going to be choosing choice A because that has our slope of 0.06. But let's just remind you how to get our B. So if we're going through here, what we do is we choose one of our values. So if I choose this first one, and we substitute it into this equation. So for f of x, we're going to put our value we have here, 580, equals, then we have our slope, 0.06, times, then we have our x value, 3,000, plus b. So now if we go through here, and I just simplify this, 0.06 times 3,000, see that that is equal to, 0.06 times 3,000 is equal to 180. So this will simplify here to 580 equals 180 plus b. Then to get b by itself, subtract 180 from both sides. And we have 400 equals b. So now that we have our a, which is our slope, our b, that is our y-intercept, we could write our function f of x equals a 0.06 times x, then plus 400, which again is choice A. All right, if we keep going down here, it says, so now we're going to get into exponential functions. It says, recall that the general formula form of an exponential function is f of x equals a times b to the x, where a is the initial value, or the y-intercept, and b is the base. Just as with linear functions, you can write an equation to model an exponential function from a pair of input and output points in the table of values, from a graph, or from a verbal description. To write the equation for the exponential function, determine the initial value, right, which is our a, or the amount, and substitute that for a in the general formula. Then determine the rate of growth or decay, which is the base of the exponential function, by finding the common quotient from one output to the next. Substitute that for b in the general form, and then you have your equation. So if we go on and we take a look on the next page here, we have an example. So they gave us an example. It says Hallett invests $500 in a bank account that pays 5% interest compounded annually. The table below shows the amount of money to the nearest dollar in Hallett's account over time if he chooses not to invest any more money into the account. So as our input increases by 1, right, we can see what our output increases there. So it says, which function best models the function f of x, the amount of money in the account after x years? So we have our formula, f of x equals a b to the x here, with our a being our y-intercept, which is when x equals 0. So right away, we can take a look at this and see that when x is 0, our a is equal to 500. Now, to find b, what we have to do is we take any of our outputs and divide it by the output in front of it. So if we start with our output after 1 year, 525, we divide it by the output in front of it, 500, and we get 1.05. So this is going to be our common rate. We can check it. Let's check it just by choosing any two other ones. So let's try 608 divided by the number in front of it, 579. And we see again, we still have 1.05. A couple other decimals in there, but that just has to do with our rounding here because they just kept it as whole dollars. So our B is going to be 1.05. So then when we combine this together, we still keep f of x equals, then we put our 500, then in parentheses, our base 1.05 to the x. So when we're looking here, we have choice C, which shows that it increases. If you look at choices choice A really is kind of the closest one here, you see this is 0.05. So this, because this base is less than 1, it would actually show the amount of money going down. So both of these we could get rid of for that reason. But if we take a look, choice C is our correct answer. All right, so now we're going to take a look at some problems to do on your own. We've only got 4 problems in this chapter, not too long, and these ones shouldn't be too bad. So if we take a look, the first one here says, a train travels at a constant rate of speed towards its destination. The linear function modeled by the graph below shows the distance the train is from its destination after traveling x hours. What is the equation of the function modeled by this graph? So again, we have f of x. This is a linear function, right? It's a constant rate of speed. So we're going to have equals ax plus b, where our b is the y-intercept, or the value when x is 0, and our a here is our slope. So if I want to start, I'll put a equals b equals, just so we have a space. When I'm looking at this graph, right away I can find the y-intercept. It's where our line crosses the y-axis at 0, 350. So our b is 350. So if we're looking at our multiple choice questions, right away we can eliminate C and D. Now, to find our slope, we pick any 2 points. So on here, the first point I'll pick is 0, 350. And then our second point, if we go over to 1, up to 300. So 1, 300. So now if we want to find our slope, all right, we take our 2 points here and we find the change. So if we're starting here, we have 300 minus 350, which is our change in y, over 1 minus 0. 300 minus 350 is going to be negative 50 over 1. Negative 50 over 1 is just going to be negative 50. So if we're taking a look here, we put this all together. F of x equals, we put in our slope, negative 50, then we have x, then our y-intercept, plus 350. Look for the answer that matches. and it's going to be choice B, which has a negative slope. If you look at choice A, it has a positive slope of 50, so that would actually show this line starting at 350 and then increasing as opposed to decreasing. All right, going down to number 2. Number 2 says Mehmet buys a new cell phone and he also pays a service fee each month to use the phone. The table below shows total cost for the cell phone and service fee each month for the first 6 months. Which statement is true and the data in the table here? So here, if we're taking a look at this situation, right, we're going to have, again, if we look at our numbers from 90 to 130, we're increasing by 40. From 130 to 70, increasing by 40. All the way down here from 250 to 290, we increase by 40. So this is going to be a linear function. So we have f of x equals ax plus b. When we're talking about a cell phone, he pays a service fee each month. So our slope here is going to be the service fee because this is something he pays each month to use the cell phone. And then also he bought a new cell phone. Well, that's going to be our y-intercept because that's where he started. After buying that one cell phone, that's where it starts. So here, this is his one-time cost or the cost of the phone. So again, to find our equation of a line, right, we need to find the A and we need to find the B. So looking at this table here, we don't have a month 0, so we don't have a y-intercept. So first, let's find our slope. So we'll pick any 2 points. So we can take 190, write it as an ordered pair. Then we can also take 2 and 130, write them as an ordered pair. And then we'll find the slope. So remember the slope, we have x, y, 1, 1, 2, 2. Take y2, so 130 minus y1, which is 90, over x2, which is 2, minus x1, which is 1. We'll see here that it's 40 over 2 minus 1 is 1. So our slope is 40. So each month it increases by 40. So then if we want to find our y-intercept, we take 1 point. So I'll take the first point and we substitute it in for our formula. So f of x equals ax plus b. Substitute for f of x, our value here, the output, or our y there. So 90 equals, we take our rate, 40, and we substitute in our value 1 for x plus b. 40 times 1 is 40. So if I want to get b by itself, subtract both sides 40, and we get that 50 is equal to b. So then if I was to write this final equation here, I'd have f of x, right over here, equals 40x plus 50. So 40 is how much he pays each month, and 50 was the cost of a cell phone. So if we're looking here, we want to look at the ones that say the monthly fee is 40. So that's C and D. So right away we can get rid of A and B. And then our y-intercept, which is the cost of the new phone, is 50, which leaves us with choice C. All right. All right, so now let's go on to the next one, question 3. So question 3, we finally get into writing a different type of function here. So for number 3, it says a certain substance decays at an exponential rate. So what's the exponential rate? We know it's an exponential function, so this is going to be f of x equals a, then b to the x. The amount of the substance on any given day is 50% of the amount of the substance on the previous day. Which function best models the amount of 1,000 grams of substance remaining after x days? So a is always our initial, or what we start with, and b is the rate of decay in this place here, or in this case here. So what we start with was 1,000 grams. So that is our A. Then the rate of decay is 50%. Now 50%, we need to write this as a decimal. So we would take 50 divided by 100, and we would write this as 0.50. Then we just plug it into our equation here. So f of x equals our initial rate, 1,000, times the rate of decay, 0.50, and this is always to the x. If we're taking a look here, choice 1, we're multiplying by x, so that's actually written more like a linear function would be. Choice B, we look here, choice B has our initial of 1,000, has our rate, and the rate is to the exponent. So this is actually going to be our correct answer. Choice C, just kind of added. I don't really know what they did here. And choice D has our rate would actually be showing growth because this base is bigger than 1. So here, choice B is our correct answer. So see how we have it written here with the exponent outside the parentheses? Because of order of operations, right? We'd still do the parentheses then the exponent. So that would work, but we can also put that exponent inside of the parentheses as long as it's still an exponent. All right. Last problem here. It says, Beatrice recorded the temperature of a cup of hot water as it cooled during an experiment. The graph below shows the temperature in degrees Fahrenheit of the cup of hot water X minutes after cooling. Write a function that models the situation. Show or explain all the steps that we use to determine this function. All right, so what I'm going to do here is take a look at the function here. First, we want to see, does it look linear or exponential? So here, you can kind of see as we're going down here, that this looks like it's more like an exponential function because it's not a straight line, right? If I was to take a straight line here and connect 2 points here, you'd see that it's not a straight line, right? It's a curve, so we're going to deal with an exponential function. So when we're dealing with an exponential function, we need to get some values here, right? So first we have our formula, f of x equals a b to the x. So a is our initial value, or at 0, what is the value of the function here? So here, if we go from 0 up, we can see that it is at 200. So 200 is our initial, and now we need to find the rate that it decreases. So what I'll do is make a quick table here with our x and then our y, or our f of x. So when x is 0, y is 200. We take a look, another point, we look at 1. When x is 1, y is directly in between 160 and 180 at 170. All right, then if we keep going, we start to get into more not clear exactly what that value is, right? That could be like 144, 143, right? So we can just stick with these two numbers here though, because we can find, if we know it's going to be an exponential function, we can find the rate just by taking our 170 and dividing it by 200. So if we take 170 divided by 200, we'll see that our rate of decay here, our rate of decrease is 0.85. So then if we want to write our function, we have all the information because all we need is our a and a b. We can write it as f of x equals the initial value, or our starting point, 200, then times our rate, which is 0.85 to the x. And this is our exponential function that models this situation. All right, so this is the end of lesson 7, and this is the end of module 3. So make sure you go through and complete any of the quizzes. If you have questions, make sure to reach out and keep working hard.